Hello and welcome to Excellence Link Academy. For today, we'll be discussing about a very important concept in differentiation known as higher derivative, right? So higher derivative. Put down, given a function f of x, or perhaps given a function in terms of x, given a function in terms of x, that is f of x to be equal to y. Given a function in terms of x, that is f of x is equal to y. The first derivative of this function, becomes f prime of x, which is equal to what then? Dy over dx. So given a function in terms of x, that is f of x is equal to y, the first derivative becomes what then? F prime of x is equal to the square is equal to dy over dx. The second derivative of this function, put down, the second derivative of this function becomes f prime of x is equal to what then? The squared y over the x squared. The second derivative of the function becomes what then? F prime of x, which is equal to the squared y over the x squared. The third derivative test, or perhaps the third differential equation of this one here, becomes f prime of x is equal to what? The cube y over the s cube. While the fourth derivative of this function becomes f prime of x, which is equal to the 4y over the x over 4. So I have this. So it continues this way. So note that if I'm given a function, for instance, y is equal to something, if I differentiate that question, I'll have the over the x as my first derivative. If I differentiate the value of the over the x, it becomes what the value for the square over the x squared. If I differentiate the value here, I'll have the cube y over the s cube. Finally, if I differentiate that term again, I'll have the b to the power 4y over s to the power 4. So note that if I'm given a question under differentiation, and I differentiate that question, I just differentiate it once. That's what the over the x. That question, the answer for the over the x, if I differentiate the answer again, I'll have the square over the x squared as my value. The answer for the squared over the x squared, if I differentiate the answer again, I'll have the cube y over the s cube. The value for the cube y over the s cube, if I differentiate again, I'll have b to the power 4y over x to the power 4, and it continues that way. Sample problem. Example. If y is equal to x to the power 5, if y is equal to x to the power 5, prove that, or perhaps show that the 6y over the x6 is equal to 0. The question says, if y is equal to x to the power 5, prove that, or perhaps show that the 6y over the x to the power 6 is equal to 0. This simply means we have differentiated this question 6 times. That's the concept. So now, bring out the question, solution. The question says y is equal to x to the power 5. First things first, if I differentiate this concept using general method, what do we know? We said differentiate right at the power. So I'm differentiating y with respect to x becomes the y over the x to be equal to what then? 5x to the power 4. We know, I believe we should know about this now. This is my double over the x. To get the squared y over the x squared, I'll differentiate this man here. Differentiate 5x power 4 Of course, I'll have 20x to the power 3. So 4 times 5 is 20. Put your s down. 4 minus 1 is 3. I have this. To get the cube y over the x cube, I will simply differentiate this man here. So if I differentiate this man here, I'll have 60x squared. 3 times 220 is 60. X is 3 minus 1 is 2. To get the 4y over the x to the power 4, I'll simply differentiate this man here. So if I differentiate this man here, I'll have 120x. Finally, alright, please, the question says x to the power 5, please, x to the power 5. So if y is equal to x to the power 5, prove that the fifth y over the x to the power 5 is equal to 0. So the 4y over the x to the power 4 is equal to what? 120x. Finally, the fifth y over the x to the power 5 is equal to what? If I represent 120, I'll have okay. If I represent 120x, I'll have 120. Finally, okay. All right. Listen. The question is quite correct, right? It's 6. It's quite correct. So it's quite correct. I made a mistake. So the question says, if y is equal to x to the power 5, prove that the 6y over the x to the power 6 is equal to 0. So we are here. Now, finally, we need to get the 6y over the x to the power 6. So the 6y over the x to the power 6 is equal to differentiate 120. Of course, 120 is a constant, so I'll have what there? I'll have 0. So proved. So that's how to prove this concept. So the question is quite correct. Listen, this is what the 6y over the x to the power 6. So it's 0 here. And I have my 0 here. Let's take another example on this concept. Alright, example 2 says that if y is equal to exponential 4x, find the fourth y over the x to the power 4. Alright, our task says to record the shortcut to solve problem under exponential function. Let me just recap. I said for exponential function, I will simply drop the link in the description of this video. So check this description. You see a video there that will take you to our exponential class shortcut. So if let's say I have y is equal to exponential 2x. For the shortcut, we know that I'm repeating y related to x becomes what? The y over the x is equal to. The first task is that differentiate the power. If I differentiate 2x, I'll have 2. So this is my 2. Next up times everything here, exponential 2x. My final answer becomes the y over the x is equal to 2 exponential 2x. That's all. That's the shortcut. Right? So let's apply this shortcut here to solve this one here. Applying the shortcut, first is first. My first task is to get the y over the x value. So solution. I'm given that y is equal to exponential 4x. First is first, get the y over the x value. The y over the x is equal to differentiate the power here. If I differentiate the power, I'll have 4. Then repeat the question, exponential 4x. That's all. Next up, let's get the squared y over the x squared. That becomes differentiate the power here. If I differentiate 4x, I'll have 4. Then repeat on the question here. Let's say into 4 exponential 4x. Now 4 times 4 becomes 16, or perhaps let me just put it here. Becomes 16 exponential 4x. Right? So this is my value for this squared y over x squared value is this. Next up, I need to get the cube y over the s cube, which will be equal to differentiate the power. What's the power? That's 4. That becomes 4 times 16. Next up, exponential 4x. If I multiply 4 times 16, I'll have 64, right? I'll have 64 x exponential 4x. That's it. Sorry, 64, just 64 exponential 4x, right? Divided the part. If I divide 4x, I'll have 4. Multiply by all the functions here. I have this. So 4 times this is 64. Next one, exponential 4x. Let's get b to the power 4y over the x to the power 4. Simply what the differentiate is man, that's all. If I differentiate 4x, I'll have 4 multiply 64 exponential 4x. Of course, my final answer for the fourth y over the x to the power 4 because what the 256 exponential 4x. So that's my answer after solving this one here. So that's like that's like the concept behind higher derivative. So know that for higher derivative, you go to differentiate something twice or thrice or 4 times, 5 times, and the likes. So let's take one more example and end this concept. Alright, example 3. Let's say we're told to find, let's say we are given that if y is equal to 2x plus 4 to the power 7, find the fifth y over the x to the power 5. So, how do you solve this? First, let's get the y over the x value. That's all. So, my solution here is to get the y over the x value. So, I'll have that the y over the x here, or perhaps, let me write out the question. The question says y is equal to 2x plus 4 all to the power 7. This is a question on what? A question on chain rule. So for the chain rule shortcut, I will also drop the link in the description of this video. So check on how to differentiate chain rule using shortcut, right? So for the shortcut, it's quite simple. Let's say I have y is equal to 2x plus 3 all to the power 2. The shortcut is that the y over the x is equal to, put this part, these two, put it down, write out the part, next up, times, differentiate the term in brackets. If I differentiate 2x plus 3, I'll have 2, times, repeat the question, 2x plus 3 all to the power 2, minus 1 from the part, minus 1 from the part. Final answer here, the y over the x is equal to 2x plus 3 all to the power 1. Or perhaps it's still like this. This is like the shortcut to solve problems on chain rule. So apply the shortcut here. We said the y over the x will be equal in value to, put down 7 here, I have 7, times, differentiate the term in brackets, I'll have 2. Next up, repeat everything, 2x plus 4 to the power 7. Next up, minus 1 from the part. At this point, the y over the x is equal to 2 times 7 is what then? 14 into 2x plus 4. Then what then? I have 6. I have 6. This is my y over the x, and I'm moving to the fifth y over the x power 5. Next up, if I do this manually, to get the squared y over the x squared, I will do this one here. So I'll put down 6 here. That becomes 6 times what then? 14 separately. Next up, differentiate the term in brackets. That's 2. Next up, repeat the term in brackets. 2x plus 4 into what then? 6 minus 1. Final answer here, the squared y all over the x squared will be equal to 6 times 14 times 2 is what then? 168. Next up, I have 2x plus 4 all to the power 5. I've gotten my value for the squared y over the x squared. Let's get for the cube y over the x cube. So the cube y all over the x cube will be equal in value to, we said, put on the part, that's 5 times what I'm seeing here, 8x. Next up, differentiate the term in brackets. I'll have 2. Next up, repeat the term in brackets. That's 2x plus 4 all to the power 5. Next up, minus of the power. That will just set earlier. If I multiply all this, give me value please.
1680.
The cube y over the s cube is equal to 1680.
680.
What then? 88. 80 into 2x plus 4 all to the power then 4. This is the value for the cube y over the s cube. Next up, let's get the g to the power 4y over x to the power 4 value. So to find that becomes the 4y over the x to the power 4 is equal to, differentiate this man here. I'll put 4 down times what I'm seeing here, 1680. Next up, differentiate the term in brackets. That's we're having 2. Next up, repeat the question. I will repeat this man here. I'll have 2x plus 4 all to the power then 4 minus 1. Final answer please. The 4y over the x to the power 4 is equal to, multiply this what?
13,440.
40 into 2x plus 4 equal the 3. Alright, this is my value for the 4y by the x to the power 4. Let's get an answer for the 5th y. The 5th y over the x to the power 5 is equal to, write 3 down, multiply by this man, 13440. Next up, differentiate the term in brackets, times 2, I have 2. Next up, repeat the question, 2x plus 4 all to the power 3 minus 1. Final answer for this man here becomes, my final answer there becomes
80,640.
the 5th y over the x to the power 5 is equal to the
80,640.
640. Next up, 2x minus 4. What's for the all to the power 2?
Plus 4.
Huh?
2x plus 4.
Okay, plus 4. Alright. Plus 4 x to the power the half is power 2. So this is like how to find the derivative of a given function.